Hi everyone, I am sorry that I can't be in school today to go over Unit 9 Lesson 3 with you, so you're going to have this video for me instead. You will like your calculator out, especially later on. I'm going to ask that you try some of the practice problems for yourselves as long as time is left. In addition to that, if you'd like to pause for a second so that you can get your sheet set up, maybe if you want to split screen or something like that, or go back and forth, that's fine, but also pause to go ahead and do the do now. So what we will do now is go over this. So you should have read that for yourself, okay? And we're going to be able to determine if this is a proportional relationship, if she drove at a constant speed, by finding the unit rates, as I mentioned in the hint. So you have the distance and the time. So her distance in miles and her time in hours will be creating miles per hour if we do unit rate. So for the first part, 65 divided by 1 would give us 65 miles per hour. Then we would have 120 divided by 2, 120 miles divided by 2 hours specifically, giving us 60 miles per hour. Our next one, 195 divided by 3, if we end up doing that, we get, oh, I typed it in wrong, 65 miles per hour. And then if we proceed on to do 220 miles in 4 hours, if we do that division, we get 55 miles per hour. And lastly, 300 divided by 5, we get 60 miles per hour. So our answer is no, it's not a proportional relationship. No, she did not drive at a constant speed. The reason we can tell, if we wanted to support our answer, especially if I had said explain why, is that all of these unit rates were not the same. If it was supposed to be proportional, or it was supposed to be a constant speed, they all would have been the same value, completing those divisions. So when we divide two items, a y divided by an x, we can end up creating a proportionality if all of those numbers end up being the same. In this case, we don't. But if we do, okay, there is an equation for a proportional relationship. So in this equation, you will notice a couple of things. You'll notice an x and a y, which comes from given information, our points, if you will, if we were plotting these. So we have something that is an input value, something that we are starting with, x, and the results that we get when we look at that. For example, if we had an input of 2 hours, our output would be 120, the y value. Because we put in the fact that she drove 2 hours, we get back the information that she traveled 120 miles. So there's a give and take there. What's not described is what k is. Okay, so that's what you see down below. K is that constant of proportionality. So this equation would only work for situations where there is a proportional relationship. So this equation does not work for our do now. We're going to be looking at examples where it does work. And if all of these divisions that we had done from the do now work out, that value that they all come to is called the constant of proportionality. Okay, so we call it K. All right, this will only work if all of those divisions are the same. I can't stress that enough. So let's go ahead and take a look at our first example, which is on the next page. Okay, so example number 1, we have a table. Okay, it's showing the number of hours that Jessica spends babysitting, so we can see that as our x value, and the amount of money she has paid. So if we know a certain amount of hours have passed by, then we know, or we can determine how much money she makes, an input and an output. We put in the information in hours, we get back how much money she made. So it says for part A here, is the relationship between the hours worked and the amount of money earned a proportional relationship? So just like the do now, we could set up all of these divisions. 45 divided by 3, 60 divided by 4, 105 divided by 7, 150 divided by 10. You can see the table skipped over some places here. All right, but if we do all of these divisions, we will be able to determine, okay, that 45 divided by 3, 60 divided by 4, 105 divided by 7, and 150 divided by 10 are all $15 for every 1 hour. They all have the same unit rate. Therefore, we can say they all have this same value of a constant of proportionality. So is the relationship between the hours worked and the amount of money earned a proportional relationship? Our answer is yes. Okay, the unit rate is the same every single time, no matter how many hours are worked, meaning she doesn't earn more money if she goes for a certain amount of time. It's always the same rate, $15 an hour. So we can actually follow it up with what is her constant rate of pay. Her constant rate of pay was determined by doing y divided by x, the output divided by the input. That constant of proportionality k, we figured out, was $15 an hour. So if we, as is stated up top, determine that x is the number of hours worked and y is the amount of money earned, use the constant rate of change as the constant of proportionality to write an equation. So if you remember from the last page, it was y equals kx. So since the number of hours she might work could change, and therefore the money that she makes could change, the only thing we fill in here is that k value. So we will make an equation called y equals 15x. So if I knew 1 hour was all she worked, I'd be able to put in 1 for x, and we would do 15 times 1 to figure out how much money she makes. 2 hours, 15 times 2. And then all the values from our table also fit this description. 15 times 3 is 45. 15 times 7 is 105. So this is describing how that chart works. For D, use the equation from part C to determine how much money Jessica will receive if she works 20 hours at the same rate. So as I was just explaining, hours was the x value in our table. And because 20 isn't not from our table, what we had to do was use the information that was provided to us. So this table turned into this equation because we saw that it was proportional. Now that I know it's proportional, I can take this equation and I can bring it down and use it to my advantage here. So if I bring it down, y equals 15x, well, 20 hours is basically saying x equals 20. So I go ahead and I put that in, and all we have to do is 15 times 20 in order to determine what her rate of pay would be for 20 hours. So if we do 15 times 20, we get 300. So therefore, she would make $300. So just because it is a word problem, I'll make it a full sentence. Okay, so Jessica earns $300 for 20 hours. There we go. All right, so that kind of idea can all be clustered together and not have to be written out as an A, B, C, D into a question too. Okay, so we can just say it all at once. 2 pounds of pistachio nuts cost $19. 3 pounds cost $28.50, and 8 pounds cost $76. Determine, is the relationship between the pounds of nuts and its cost a proportional relationship? If yes, determine the equation that represents this situation. So we don't know if it is similar to the problem we just completed or not yet until we find those unit rates. So those unit rates will be the amount of money, which we will be calling y if we had that in a table, divided by how much we knew that we had in pounds, in first case 2 pounds, or $28.50 for 3 pounds, or $76 for 8 pounds. So if we do all of these calculations, okay, we will determine if they are the same or not. If they are the same, great, we can do the follow-up question because they were proportional. If they are not the same, we can't do the follow-up question. So 19 divided by 2 gives us 9.5, or $9.50 per pound. If we do $28.50 divided by 3, we also get 9.5, or $9.50 a pound. If that happens again, we're good to go. 76 divided by 8 is 9.5, or in this case, because it's money, $9.50 a pound. So we do have enough information to go off of. We know that this is true, so we can go ahead and say K is equal to 9.5. So in y equals kx, we would write it as y equals 9.5x. So our answers to this are yes because they had the same unit rate, and there's our equation that would go with it. So now, I didn't ask this on the paper, but I could say, okay, how much is 7 pounds? How much is 10 pounds? How much is 1,000 pounds? It doesn't matter. We would be able to put any of those numbers in for X and be able to figure out what the cost would be. Vice versa, I could also say the cost, and we could put that in for Y and figure out, okay, if I paid that much money, how many pounds would I get? All right, so we have that. Let's go on to another one, also condensed like that one was. All right, so here's number 3, but this time the information has been given to us within a table. So use the table below to determine if the relationship between X and Y is proportional. So no other information is given to us. We don't know what X and Y stand for. So this is as basic as it can get. It's not a real life problem. It's more just, do you have the math knowledge to do this? So as we said before, if it was true, K should equal Y over X. So if I go ahead and do all of these Y's as the numerator and all of these X's as the denominator, we're going to be able to follow through and work out this problem. Again, there's a follow-up question. If our answer is yes, determine the equation that represents this situation. Well, 6 divided by 1 is 6. 8 divided by 2 is 4. 10 divided by 3 is, annoyingly, a repeating decimal of 3.3 repeating. 12 divided by 4 is 3. And 14 divided by 5 ends up being 2.8. So it is not a constant value, all of these unit rates. Therefore, we do not have a constant of proportionality. And if we don't have a constant of proportionality, they are not proportional. So our answer would be no, the unit rates are not equal. No follow-up question needed. And lastly, some more information given to us this time, more context. For a school field trip, there must be one adult to accompany every 12 students, 3 adults to accompany 36 students, and 5 adults to accompany 60 students. Show that the relationship between the number of adults and the number of students is a proportional relationship, then write the equation. So they're actually telling us that it is proportional. So when we do K equals Y over X, we will notice that 1 over 12 is the fraction 1/12. 3 over 36 can be reduced to 1/12 because 3 goes into both those numbers. And 5 over 60, 5 goes into both those numbers to reveal 1/12. So we have a constant of proportionality. We know it this time. It is 1/12. So if we wanted to transition to use the fact that K equals 1/12, we can say in the equation Y equals Kx for something that is proportional, Y would equal 1/12 of X. And that does kind of check out because 12, if we put that in, 1/12 of 12 is 1. Or 1/12 of 36 is 3. And 1/12 of 60 is 5. And you can test that on your calculator if you really wanted to. All right, so here's what I'm going to say, because it doesn't take too long to do those things with the do now, is if you feel like you need to, rewind, go back, and listen to what I said about things being proportional or not proportional. If you feel like you kind of got the idea from these 4 examples that we did, go on and try the practice on your own. You can pause this video, but when you come back, what I'll be doing is I'll be going over the practice questions with you. I already have them written out since you're supposed to be trying them on your own, but then you can check to see if you're right. Okay, so please pause and try those on your own or go rewatch, whichever you feel like you need to do. All right, so let's go over these practice problems. So we'll do them one at a time. So here is practice problem number 1. Okay, so what you can see is I did the number of words per minute. I found a unit rate for all of these, and they all ended up being 45. And so since they all became 45, I know that I do have a constant of proportionality. So I put that in the K location in our equation Y equals Kx. This one should have been Y equals 45x. And yes, it was a proportional relationship. Okay, for 2a, what you can see here is that I have 2 tables. Okay, the one on the left and the one on the right are both proportional because on the left we had all of those divisions give us 6, so y equals 6x. And on the right-hand side, all of those were fractional, but they reduced to the same fraction, 2/3. So y equals 2/3. On number 3, it was broken down into parts again. So it says Chris earns money by cleaning up his neighbor's leaves. He charges $31.25 for 5 hours of work and $50 for 8 hours of work. Is the relationship between hours worked and amount of money a proportional relationship? We can say yes, it is, because when we find the unit rate per hour for both of those situations, it was $6.25 an hour. So that actually is also the answer to our follow-up question. Since yes, this was a proportional relationship, that matching value is the constant rate he was paid at. Part C was let X represent the number of hours worked and Y represent the amount of money earned. Okay, so you can kind of see here that the amount of money earned, being Y, was what was on top. And let X represent the number of hours worked. Well, I put that on the bottom. So we are doing Y divided by X. Okay, and so since Y divided by X is what we did, that is what K should equal in a proportional relationship. So that in this case was 6.25. So that's why I made Y equals KX, Y equals 6.25x. Using this equation, what we can do is use it for two things. One, which was part D, use the equation to determine how much money Chris will receive if he works 20 hours at the same rate. So since X was the number of hours worked, I put that where X goes in the equation, and 6.25 times 20 is 125. And since Y is amount of money, that is $125. It was a reversal in part E. Chris wants to buy a PlayStation which costs $300. How many hours will he need to work in order to have enough money to purchase the PlayStation? So now we were given hours, so that went in for Y, 300. And we have 300 equals 6.25x. So we would have to divide 6.25 on both sides to solve for x. 48 is the answer, and x was the number of hours, so I put the unit there, 48 hours. Okay, so the minimum that I would guess this lesson should have taken if you understood everything was about 25 minutes. That's what we should be at right now. So at this time, you should notice that the homework that goes with this has been posted. If you feel like you needed to, you could go rewatch the other sections that I described, or if you had done that already, you might be a little bit past that point. But hopefully before the bell rang. So you have the homework that you can do in that situation still. I will be back tomorrow, and I hope all of you have a great day.